designing or developing a reliable data transfer protocol, and short name for that is provided as RDT, and we'll be designing it step by step. This is a important thing because, as I have told you, that suppose you want to use UDP as a transport service, uh, because of the needs of the application, but you want some type of reliability in application layer, then you need to think of how to transfer data reliably. So this particular topic is not actually hinged with strictly hinged with transport layer. It is can be important in application layer, link layer also. Link layer, when I say is link layer between two routers, the point-to-point link between two routers, and it is within the top 10 list of most important networking topics. And we are going to use finite state machine. You might have done a course in automata theory, Tanmay.
Yes, sir.
So what is automata theory, or what is finite state machine, or any automaton? Just a minute. I'm in a class right now. Okay, so we are going to use finite state machine, and as we know that finite state machine, that it is having states and then transition from one state to another state. This you might have seen in your automata theory course. So state 1 to state 2, and then there is a transition from state 1 to state 2. So using finite state machine concepts, we are going to design a reliable data transfer protocol. So what actually you want to provide, what transport layer want to provide the application layer, is a reliable channel. This is what is the goal of reliable data transport protocol. This is the service which is going to be provided to the application layer. That sending process at one application layer on one host should send data, and that data should be reliably transferred to the receiver process running on another machine. So what transport layer wants to provide is a reliable channel. But what is the reality? Reality is that your channel is unreliable. So means channel means the layer below, that is a network layer or the internet or the network, packet switch network, is unreliable. So what you want to create by hiding all the problems of unreliable channel, a reliable channel. You want to create a reliable channel by solving or hiding all the problems that can be created by unreliable channel. This is what is the goal. Means application layer will send the data and using a function RDT underscore send. This is reliable data transfer protocol sending side. This will send data to the unreliable channel. So UDT underscore send, fine. Then the data will be received, RDT underscore receive function, and then the data will be delivered to the application layer. And here sits in between your application layer and reliable channel, your protocol sits, which actually, after solving all the problems and challenges of unreliable channel, is going to provide a service which is equivalent to a reliable channel. So there are four functions. Application layer will invoke a function RDT send. This RDT protocol will invoke a function UDT underscore send. Then transport layer will invoke a function RDT underscore receive to receive the data from unreliable channel. And then data will be delivered when transport protocol will invoke a function deliver underscore data. Now, what is going to be there, and that is very important, that depending upon the characteristics of unreliable channel, your complexity of protocol will increase. So what we are going to do, we are going to slowly and gradually increase the problems which can be there in unreliable channel, and slowly and gradually we'll be developing different versions of this RDT protocol. And that's what is the goal of today's lecture. So we'll introduce one challenge, then solve that, then introduce one more challenge, then another challenge, and slowly and gradually we'll be developing a reliable data transfer protocol. Now suppose how the how things are going to be there. When application wants to send data, it will invoke a function RDT send. That data will be sent by UDT underscore send to unreliable channel, as I told you. Then receive side will invoke RDT underscore receive and then deliver the data by deliver underscore data. This is how the things are going to be there. Suppose this is called from above, RDT underscore send is called from above, example by application, and the data will be passed to the pass data to deliver to receiver upper layer. UDT underscore send call by RDT, reliable data transport protocol, to transfer packet over unreliable channel. RDT underscore receive called when packet arrives on the receive side. Deliver data called by RDT to deliver data to upper layer. What we are going to do, as I told you, we'll incrementally develop the sender receiver sides of reliable data transfer protocol. We'll consider only unidirectional data transfer, but control information may flow in both directions. We'll use, as I told you, finite state machine to specify sender and receiver. So it would be like state 1 to state 2, and then events or action, events causing the state transition and action which are going to be taken on a state transition. This is what is going to be our model. So we are trying to develop, we'll be trying to develop abstract machine which can be translated into code directly for reliable data transfer protocol. Just a minute. मेरी चर्चा हो चुकी है आईजी साहब से, और मैंने सीआई से भी इनपुट ले लिए हैं। आपकी तरफ से इनपुट आने की मेरी बात हुई थी, तो एसपी मतलब एग्जैक्टली आपको चाहिए कि आपने जो मेरे को दिया था वो तो ठीक है, मैं कुछ चीजें तो समझता हूँ, तो कुछ कुछ बातें मेरी आईटी साहब थी, वो मैं 19 तारीख को मोस्ट प्रोबेबली आ भी रहा हूँ। ठीक है, अभी कल ही बात हुई है आईटी साहब से, तो वो 19 तारीख को मैं आऊंगा भी और वहीं इकट्ठे बैठ के ब्रेनस्टॉर्मिंग करेंगे। ठीक है, मुझे 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 ये चाहिए था कि जो सराउंडिंग येलो जोन है उसमें उसमें आपको सुरक्षा के लिहाज से क्या क्या चीजों की आप सोच रहे हैं और उसमें टेक्नोलॉजी कैसे मदद कर सकते हैं। तो वो एक चीज क्राउड कंट्रोल एक हो गया है। आवाज कट रही है आपकी। हेलो 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 हेलो। So what we are going to do is we are going to incrementally develop the sender and receiver side of this protocol. We'll be considering only unidirectional data transfer. Just a minute. सर आपकी आवाज कट रही थी सर। हेलो हेलो हेलो। हाँ सर आवाज बहुत कट रही है आपकी। हाँ हाँ। Fine. So finite state machine will be developed. Uh, Events which can cause a state transition, action which are going to be taken on a state transition. So let's start developing this protocol by a very simple step. Suppose we assume that underlying channel is perfectly reliable, no bit errors, no loss of packets. And in this case, if we have to create a finite state machine, how it will be created? Because there is no loss of a packet, there is no bit error. And if you want to have a separate FSMs for sender and receiver, so it will be very simple. A single state sender wait for call from above. And as and when a data arrives from application layer, see the mouse pointer, the action event will be RDT send data. Action on that event will be make packet of that data and then utilize UDT send. Remember UDT send to send the data, send the packet, and then again come back to this state and wait for call from above. Similarly, receiver side, RDT underscore receive the packet, and deliver the packet. After receiving the packet, you can extract data from the packet. This is the action. This is the event, RDT receive packet, extract data from the packet, and then deliver that data to the application. So we call this protocol version is RDT 1.0, where the assumption is that reliable transfer over reliable channel, you are not required to do anything. So the finite state machine, both at sender and receiver, are very simple, as you can see. Now suppose we introduce a channel which can not lose packets. Packet loss is not there, but can have bit errors. Underlying channel may flip some of the bits in packet. And then there is checksum to detect the bit errors. Now, how to recover from errors? Suppose you say something to somebody and some of the words are lost. So what other person will do? Tanmay, suppose I'm talking and some of the words are lost due to some noise in the channel. You are not able to hear some of my words. What do you say, Tanmay? Or anybody?
Sir, I'll ask you to repeat.
You'll ask me to repeat. Simple. Uh, so how to recover from errors? Receiver will explicitly tell the sender that packet received is okay. And if the packet received is having errors, receiver will explicitly tell that packet is having some errors. And on receiving the negative acknowledgement, sender will retransmit the packet. And means we need to have some new mechanism in RDT 2.0 which are beyond RDT 1.0. The error detection, some function is there, has to be there, which can detect the errors the way we have seen, like checksum, and then give the feedback, acknowledgement or negative acknowledgement from receiver to sender, so that sender can accordingly move further. So what we are introducing here, errors in channel, bit errors, acknowledgement, and negative acknowledgement. Now what would be the FSM? It's very simple. Wait for call from above. Let me take the full screen snip. Means this state waiting for some data from the application layer. As and when the data is received, action will be RDT, event will be RDT send, RDT underscore send data. Now action will be send packet, means you'll be making a packet and including the checksum also. And then you'll use UDT send underscore send to send the packet. Now, what is the next state? After sending the packet, the state of sender will change. Now it is waiting for negative acknowledgement or positive acknowledgement in this state. Suppose it receives a packet, receive packet, and negative acknowledgement. So what it will do? The action will be, suppose the event are receive packet and it is a negative acknowledgement. Then what? You'll again wait in this state. By action, what? Send packet. If negative acknowledgement is received, you'll do the action resend the packet, because packet is already there in this state. Once you have send a packet, that packet is in buffer, in this buffer, fine, in this state. And if a negative acknowledgement is received, you will again use UDT underscore send packet. So means this packet which we have sent earlier is again going to be resent. Otherwise, if you receive a packet and which is acknowledgement, positive acknowledgement, you'll transition from second state to initial state and again start waiting for call from above. And in this case, there is no action. So at the abstract level, you send the packet with the checksum, and then you wait for acknowledgement or negative acknowledgement. If acknowledgement is negative, then you resend that packet and again wait for acknowledgement or negative acknowledgement. If the acknowledgement is positive, you change the state and come back to initial state and wait for another packet from above. What is seen at receiver? If receiver receives a packet and after checking it, it found that it is not corrupt. So the event is this, not corrupt. Then extract the data, deliver the data to the application layer at the receiver, and send the positive acknowledgement. If you receiver receives a packet which is corrupt, then you will not extract or deliver because it is corrupt. You just discard that packet and you send the negative acknowledgement. And again start waiting for. So there is only one state at the receiver. If the packet is correct, deliver the packet, send that positive acknowledgement, and start waiting for call from below. If the packet is incorrect, corrupt, don't send it to application layer, just send the negative acknowledgement, discard the packet, and again wait for call from below. So if we see this protocol in action, suppose there are no RDT 2.0, if there are no errors, what is going to happen? We are waiting, both are waiting, packet is sent, packet is received, positive acknowledgement is sent, and you are again starting waiting. Now, if there is error, what will happen? Send the packet, waiting for corrupt packet, send the negative acknowledgement, you resend the packet again. This time it is, if it is correct, then you send the positive acknowledgement, you again wait. So this keeps on happening. This keeps on happening. Now the question here is RDT 2.0 is having a fatal flaw. Can anybody tell me what is a flaw? RDT 2.0, the protocol which we have just explained, just discussed, is having a fatal flaw. And what is that flaw? Can anybody tell me? Yes, think over it.
Sir, sender should wait for acknowledgement before sending another packet.
Sender is waiting for acknowledgement.
Sir, before sending another packet.
Sender cannot
Like
send
it cannot.
Sender cannot send any other packet. Because as and when, just see it. As and when the packet is sent, sender is in this state. Until and unless acknowledgement is received, sender cannot come back to the initial state. And initial state only it can get packet from the above layer. Got the point?
Yes, sir.
Sender cannot send packet. Sender has to wait for one acknowledgement. Any other problem? What is the problem?
Infinite looping if the network is broken.
That's another story. After few more try, you can have a check that okay, after 20 try you just drop the connection. That's another thing. They're not seeing what is the property of the underlying channel. We have just assumed bit errors. Think over it. Let's see. The problem lies here. What happens if acknowledgement and negative acknowledgement are corrupted? Sender does not know what happened at the receiver. Got the point now? Because if packets can get corrupted, acknowledgement and negative acknowledgement can also get corrupted. Sender is in no position to know what happened at receiver. You can't just retransmit because you never know whether the packet has been received correctly or not. So what is needed? Handling duplicates. Sender retransmits current packet if ACK or negative acknowledgement is garbled. But now you need to have a mechanism to discard the duplicate packet. And for that, you require to add a sequence number to each packet. So if in any case, if you come to know that acknowledgement or negative acknowledgement are corrupt, you don't know whether it is NAC or ACK, then what you can do, you can just retransmit the packet. But if that packet resulted in a duplicate packet, receiver has to discard that. And to know whether it is duplicate or not, you need to have a sequence number attached to each packet. Let's see this. We'll be using 1-bit sequence number, suppose. And now you see as and when you keep on increasing the complexity, your state transition diagram becomes bigger and more complex. So now see here, let me take the snip of this. So waiting for call 0. Now there would be two state, call 0 or call 1, because every packet is going to have a sequence number 0 or 1. So you're waiting for call 0 from above, suppose. So you'll send the data, event is RDT underscore send. Action is make a packet with sequence number 0, data and checksum, and then UDT underscore send packet. And start waiting for acknowledgement or negative acknowledgement for packet 0. If you receive a packet which is corrupt or it is negative acknowledgement, in both cases, you retransmit the packet. Either you received a corrupt packet or you received a negative acknowledgement. In both cases, you retransmit the packet and wait for again 0 and start waiting for 0. Stay in this state. If you receive a packet which is not corrupt, and which is acknowledgement, then you move from this state to this state, and now you start waiting for packet number 1 from above. When you get the packet, you send the packet with sequence number 1, and now it is repetitive. So important thing here is you'll move to 0 to 1 only when you receive the positive acknowledgement for 0. You move from 1 to 0 only when you receive the positive acknowledgement for the 1. Otherwise, what you are going to do, either you receive a correct packet or you receive a negative acknowledgement, you will retransmit that packet. So sender work is done. Now let's see the receiver, what receiver is going to have. Please be with me. Please be with me. Receiver is interesting. So just see what is happening at the receiver. We're waiting for 0 from below. We're waiting for 0 from below. So suppose you are waiting and you receive a packet which is not corrupt and has a sequence number 0. मतलब सब कुछ सही है. Packet receive किया, which is corrupt, which is not corrupt, and has a correct sequence number because you are waiting for 0, has sequence number 0. Then extract the data, deliver the data, and create a positive acknowledgement and send the positive acknowledgement obviously with the checksum. Fine, because this time you have to include the checksum with acknowledgement packet also, and then send the packet and move to wait for 1 from below. If you receive and it is not corrupt, send the positive acknowledgement and wait for 1 from below. Suppose you receive a packet which is a corrupt packet. Send packet, negative acknowledgement, include a checksum, send the packet, and start waiting for 0 again because you have received the packet which is corrupt. Wait for 0 again. Be in this state. Suppose you receive a packet which is not corrupt but has another sequence number. Now here you are able to detect the duplicate. You send the positive acknowledgement with checksum. Fine. but you don't know all these things. You don't do all these things. डुप्लीकेट पैकेट आया, उसका एक्नॉलेजमेंट तो अपने अपन ने भेज दिया भाई कि कुछ आया कुछ सही, ठीक है, बट you don't do this thing because you know the things are duplicate. Don't extract the data, don't deliver the data. That. Similarly, you're waiting for one. If you receive everything correct, send the acknowledgement. If you received corrupt, send negative acknowledgement. Keep on waiting on that state. If you receive the wrong sequence number, send the acknowledgement, but don't deliver the packet to upper layer. This is the receiver state transition diagram. Fine. And now you can see all the cases are going to be covered, and now there is no issue in this protocol. Fine. If you want to have discussion over this protocol, you can see that we have added sequence number, only 2 sequence number, because one by one we are sending, they will be sufficient. Must check if received acknowledgement or negative acknowledgement are corrupted. Twice as many state, because you now remembering whether current packet has 0 or 1 sequence number. Receiver, what receiver is going to do, must check if the packet is duplicate. State indicates whether 0 or 1 is expected packet sequence number. Receiver cannot know if the last acknowledgement or negative acknowledgement received okay at sender, otherwise there would be a cycle. Sender is not sender, after receiving the acknowledgement or negative acknowledgement correctly, is not sending anything back again. So that's clear. Now what do we want to have? We want to avoid negative acknowledgement. We want to have the same power without using negative acknowledgement. Instead of negative acknowledgement, receiver sends acknowledgement for last packet received okay. Instead of negative acknowledgement, receiver will send duplicate acknowledgement. So you are trying to remove some of the state maintenance and some of the message formats you are trying to make this protocol simple. Otherwise, negative acknowledgement and positive acknowledgement would be having different message formats. So instead of having both type of acknowledgement, we want to have only positive acknowledgement, and if anything bad is happening, we'll be sending a duplicate acknowledgement. Receiver sends acknowledgement for the last packet received, which is okay. But in this case, receiver must explicitly include sequence number of packet bean acknowledgement. Means in short, acknowledgement is also going to have some number. Duplicate acknowledgement at sender would give an indication that if it is duplicate acknowledgement, actually it is a negative acknowledgement. So in that case, sender will retransmit the current packet. This is very important and beautiful aspect, that you remove the negative acknowledgement, have positive acknowledgement only. Duplicate acknowledgement will be utilized when something bad happens. And once sender receives a duplicate acknowledgement, sender will retransmit as if considering it as a negative acknowledgement. Now see here. Now the FSM, I'm just drawing half for 0 packet. Suppose you are waiting for call 0 from above. RDT send data, make a packet with 0 sequence number and checksum and send the packet. And now wait for acknowledgement 0. You have sent the packet. Now you are waiting for, instead of waiting for acknowledgement or negative acknowledgement, you are waiting for acknowledgement 0. Suppose you receive a packet which is corrupt packet or having acknowledgement number 1, then you retransmit the packet. Suppose you receive a packet which is not corrupt and having correct acknowledgement number, then you move to wait for call from 0 from above. And then you can complete this FSM by yourself. So if duplicate acknowledgement is received, fine. You're waiting for 0 and you receive 1, or you receive a corrupt packet, then you need to retransmit. If expected acknowledgement number is received and it is not corrupt, then you move to the next state. What is happening at receiver? Receiver is going to have 2 states. You are waiting for 0 from below. You receive a packet which is not corrupt and has a sequence number 1. It is coming from 1. So here wait for 1 from below. So wait for 1 from below has received this state has received a packet which is having correct sequence number because waiting for 1. Then extract the data, deliver the data, and create acknowledgement number 1 with checksum and send the packet. Send the acknowledgement. If you receive a packet which is corrupt or has wrong sequence number, then send the packet. Means what is the packet which is there in this state? It is having the acknowledgement number 1. Because you have moved from here to here and UDT send has utilized already this argument send packet with acknowledgement number 1, which is still there with in state 0, you just send the acknowledgement number 1 again, you send the duplicate acknowledgement. So in this way, we can avoid using negative acknowledgement and still can achieve the same strength of negative acknowledgement, strength of 2.1. Now another challenge. 3.0. Now the challenge is that underlying protocol, underlying channel can not only have bit errors. Bit errors is another thing. It can also lose the packet, means drop the packet. So what is needed? Packet can be dropped, can be lost. In addition to bit errors. So checksum, sequence number, acknowledgements, retransmission will be of help, but not enough. What else is needed? Yes, anybody? Karimullah?
Sir, time limit for waiting for acknowledgement.
We require timer. We require timer, a timer which can tell that, and this is one of the most important aspect of internet, the timer. A timer which can tell that, okay, if you have waited for this much long for acknowledgement to arrive, and if you are not getting acknowledgement within that time, you can consider that packet is lost and you can retransmit the packet. Your assumption may be wrong and you can have a duplicate packet, but that duplicate packet we have already handled in the previous state transition diagram. Sender waits reasonable amount of time for acknowledgement. It retransmits if no acknowledgement is received in this time. It may be a case where acknowledgement got just delayed, not lost. Retransmission will be duplicate, but we have already handled that using sequence number. Receiver must specify sequence number of packet being acknowledgement. We have already done that in the previous state transition diagram. It requires a countdown timer, obviously. Now please be with me and understand the sender. Let me take the snap first and then you'll be able to understand it properly. Fine. Please be with me. Waiting for call from above. Call of 0. Send data. Actions are make packet data checksum. Send the packet and start the timer. That's important. And start now, change the state and now waiting for acknowledgement 0. If you receive the packet which is corrupt packet or a duplicate acknowledgement, do nothing. If you receive a packet and which is corrupt or is duplicate acknowledgement, you are waiting for acknowledgement 0 and you receive acknowledgement 1, just do nothing. Because this will be handled here. If you don't receive acknowledgement 0, there would be timeout after some time. If there is a timeout, you resend the packet. That's UDT send packet is already there in this state. You resend the packet and start the timer again. And start waiting for acknowledgement 0. Again, come back to this state. Here, if you receive the packet which is corrupt or having a wrong acknowledgement number, come back to this state doing nothing. Now suppose you receive the packet which is not corrupt and having correct acknowledgement number, you move to another state. Now start waiting for 1 from above and stop the timer. Similarly here, you send the packet, 1 sequence number, checksum, send the packet, start the timer. If you receive the correct packet, don't do anything, keep on waiting for acknowledgement. If there's a timeout, then resend the packet, start the timer. If everything is correct, stop the timer and move to this state. Is it clear? Can anybody tell me what is this?
Also like delayed acknowledgement?
Yeah, just discard that. You got the point. Because you are waiting for call from above, and in that case, if you receive a packet, fine. You're not waiting for acknowledgement and you are waiting for call from above, fine. And if you receive a packet, that has no meaning. Okay. So that may be a delayed acknowledgement, fine. And you have to discard that. Got the point. Thank you. Fine. So that is RDT sender. Let's see. Now there's an assignment for you people, and I'm giving you 10 minutes. And those who can make it can show me their work. Can you make the corresponding RDT receiver? Or you can try RDT receiver at your home later on. Fine. Corresponding RDT receiver. What are going to be the receiver action? Do we need to have any changes from this receiver? Tell me. Or this receiver will work fine? Karimullah? Tanmay? Anybody else? Okay, you can check it later. You can check it later if you want to create a corresponding receiver for this, then what you need to do. Now, if you see RDT 3.0 in action, suppose there is an operation which is having no loss. There is an operation which is having no loss. So what would be the scenario? You send the packet 0, you receive packet 0, send acknowledgement 0. You receive acknowledgement 0, now send packet 1, and everything is hunky-dory, it's going on fine. Suppose you send the packet 0, you receive the acknowledgement 0. You send packet number 1, which is lost. Obviously, if packet is lost, there would be no acknowledgement. So there would be a timeout. You again retransmit the packet and it's fine. Next. If suppose there is a lost acknowledgement, then what will happen? Suppose there is a lost acknowledgement. You have sent the packet 0, receive acknowledgement 0. You send packet 1. Packet is received correctly. You send acknowledgement 1, but acknowledgement is lost. Again, you transfer the packet, but now this packet will be detected as duplicate. But in any case, you will send the acknowledgement 1. Fine. Receive the acknowledgement 1 because it is waiting for acknowledge. Packet 1 has been sent, and things are back. There may be a situation of premature timeout. Premature timeout. So send packet 0, acknowledgement 0, packet 1, and you timed out earlier, you transfer packet 1 again. Now if you receive acknowledgement 1, things are okay. Things are okay. You send the packet 0 again. And now when this is acknowledged, acknowledgement 1 comes here, this would be that case. Delayed acknowledgement, and this should be discarded because you are waiting now for acknowledgement 0. Got the point? The case which we have seen here is this one. You are waiting for 0 and you receive another packet which is of no use. Fine. So this is how you can develop a protocol slowly and gradually with all these errors. But as you can see, if you develop transport layer protocol, TCP like protocol in this fashion, it will be a lot of wastage of resources. Fine. So I'm stopping here because you need to think about this, because the next topic will be starting the pipeline protocol, where you'll be able to send many packets in one go without waiting for individual acknowledgement. And then we'll understand the concept of cumulative acknowledgement. That okay, you can send 10 packets, and if you get the acknowledgement of 10th packet, now it can be sure that all the 10 packets have been received correctly. So this is what we are going to see on next turn. Any questions from anybody? Any questions? Okay, if there are no questions, then you can leave. Thank you.
Sir?
Yeah.
So in the RDT 3.0 receiver,
Mhm.
will there be a timeout for the receiver end as well?
Whether we need that?
So I don't think so, but
If you don't need, why do you want to put complexity in the protocol? There is no need of having timeout for acknowledgement, because you don't worry about that. Sender will be handling that.
Yes,
Look,
sir.
you are able to handle the duplicate. Suppose sender doesn't get the acknowledgement and you don't know whether your acknowledgement has been received or not. But as and when you get the duplicate packet, you'll be able to realize that. Okay.
Yes, sir. Yes, sir.
So look, that's a beauty in network application. When you are trying to design a network application, these are not only two parties which are communicating. You have to think about workable solution where one party solution can help the aspect the way you have thought. अरे यार acknowledgement भी तो टाइम आउट होना चाहिए क्योंकि पता नहीं acknowledgement पहुंचा कि नहीं पहुंचा, यही तुम्हारा थॉट प्रोसेस था ना.
Yes, sir.
बट उस पर्टिकुलर केस को तो हमने सबज्यूम कर लिया ना कि एक्नॉलेजमेंट पहुंचा कि नहीं पहुंचा, पैकेट लॉस हुआ कि एक्नॉलेजमेंट लॉस हुआ, वो सेंडर को भी नहीं पता है. सेंडर केवल टाइम आउट का वेट कर रहा है. गॉट द पॉइंट?
Yes, sir.
और अगर दोनों ही केस में वो रिट्रांसमिट करेगा, अगर एक्नॉलेजमेंट लॉस्ट हुआ है तो रिसीवर को पता चल जाएगा क्योंकि रिसीवर को दोबारा से वो पैकेट मिलेगा. बात समझ में आया?
हाँ,
तो
sir.
रिसीवर उसको डिस्कार्ड कर देगा. अभी तो this is kind of a stop and wait where one packet then another packet then one packet, only one bit sequence number is there. Think about when we have like TCP sequence number field is 16 bit, so we can have many packets lined up and can be thrown in the network without waiting for acknowledgement. Fine. This is what we are going to see next when we see sliding window protocols like go back and selective repeat, and finally what sliding window is happening in the transport layer in the TCP. Okay. So you just need to what you need to do, because the coming finite state machine would be more complex in the case of pipeline protocol, GBN and SR, go back and selective repeat. So you need to understand these, just draw the states and transition and understand whether it is able to cover all the cases according to the assumption which we have there in the underlying channel. Most important aspect is that, because whenever you get a problem, you are going to get the property of the underlying channel. So we started with only bit error. We at that point of time the challenge was bit error, so we included checksum. Then we slowly avoided that negative acknowledgement. To avoid negative acknowledgement, we needed to include sequence numbers. Whether acknowledgement is lost or not, we need to do that thing also. Fine. Then another assumption we used that okay, packet may be lost also. So you never know whether packet has reached there or not because you are not getting the acknowledgement, or you never know whether the packet or acknowledgement is lost. So then you included the countdown timer. Fine. So slowly and gradually in this manner, these protocols have been developed, and it's not about the protocol only, it's about the design. Like why we are doing it by finite state machine. Just tell me, Tanmay.
So because it follows a particular step process, so
No.
it's easier.
This is the first, because as a software engineer, you need to understand that before making a system, can you test the system?
No, sir.
It means if you go by civil engineering, you'll create a bridge across Yamuna, and after creating the bridge, you'll call 100 cars and 100 vehicles. Now let us test it whether it is okay or not. That's what you'll do.
No, sir. No, sir.
So similar thing applies in software also. After creating a big protocol, and 100 fellows have worked for 3 years, and then you are saying, let's test it. And then you come to know, no, this is not workable. So similar thing applied to software engineering also. The way you have mathematics in civil engineering that, okay, this should be the height, this should be the tension, this should be the pillar strength, this should be that. Mathematics is there, no? And then you have read these mathematics in +2. Because this should be the tension, this should be the friction, this should be that, this should be that, and this should be the beam strength. All mathematics is there. And then you create a prototype model. So before designing the system, you need to test the system. At least it should be behaviorally fine. And to test the system before making the system, without making the system, what you want? You want abstraction. So you are not actually coding the protocol. See it carefully, Tanmay, and that is the actual computer science which people don't understand. See here, and corrupt. So we are not worried about the corrupt है कि नहीं, इसके लिए तो एक और फंक्शन चाहिए ना, क्यों तन्मय?
Yes, sir.
चेकसम का हम वरीड नहीं है उसके लिए, अगर होगा तो ये होना चाहिए और इसी को डिजाइन करेंगे अभी हम. These are what? These are processes actually. State, call them state or call them abstract level processes. So in any case, any machine is going to, why you study automaton? Why you study automata theory? Because you want to create finite state machine of any reactive system. And at the level of finite state machine, at the level of that abstraction, you know what messages are going to be transferred, what events are going to occur, which can be easily coded into a programming language. That's another story. And at that level, you keep on checking. What? And this particular whole branch is known as formal methods. It's the biggest branch of computer science, theoretical computer science, where without designing a system, you can actually test and debug and verify the system. What do you think? कोई language ऐसे ही बन जाती होगी? C, Java, ये सब?
It's a long drawn out process.
So that is a process, and that's why I'm trying to make you understand that, okay, at finite state machine level, we can actually design a protocol. And then that protocol, if it is correct at that level, rest is very simple. You have to just translate these events and actions into piece of codes. Got the point?
Yes, sir.
Okay, I think we can leave. Thank you.
Okay. Thank you, sir.